All right. My name is Leandra Ford, and I'll be your tutor. And these are my twin sister and my stepbrother here assisting me with class. We'll be starting with the
Hi, good
structure of the
evening.
earth.
My name is Sasha and Ford. Nice to meet you.
Nice to meet you too.
Good evening. My name is Trashford. Nice to meet you.
Nice to meet you also.
We're starting with the structure of the earth. Right. All right. The earth. Everyone knows how the earth is already, right? The planet that we're on right now. The earth can be divided into three separate layers, and these layers are known as the core, which is the innermost layer of the earth. We hear about this in TV all the time, the molten core, the center of the earth, basically. And the middle layer, which would be known as the mantle. And the outermost layer, known as the crust. And the crust is the part of the earth that we walk on and we traverse, and where most life resides. And here the diagram of how the layers will be divided in a simplified manner. I know you can see four different labels here when I said there were three layers, but it's really just the same three layers. But the innermost layer can be further divided into two separate components, known as the inner core and the outer core, as you can see here. And we will go more in depth in this further down in the slide. Earth crust.
I
Or
just want to I just want to mention, if you don't mind, Leandre, considering the layers of the Earth, in most diagrams is showcased as very smooth, curved, clear-cut differences. However, in reality, it's very lava lampish. It's not very clear and smooth cut. That's all I would like to know.
yes, please. And the earth crust. This is the outermost layer of the earth, and this is known as the crust or lithosphere. You will hear this term interchangeably sometimes. And the crust is made up of solid rock, typically of basalt or granite rock. Later on in the slides, we will learn about the different types of rocks. And only two types of crust exist on Earth, and these are known as the oceanic and continental crust. The oceanic crust is the heavier of the two crusts, even though it's the thinner of the two. This is because it is mainly made up of basalt rock. And the continental crust. This is the lighter and thicker of the two, and is mainly made up of granite rock. And these two different compositions that make up these two separate crusts will change the weight and the density of two separate crusts. The Earth's mantle. This can also be referred to as the mesosphere, and this is the layer of the Earth that is located between the Earth's crust and the layer that, and is the this is located between the Earth's crust and the core of the Earth. And this is the layer that makes up most of the Earth's volume, that takes up most of the space. It is made of hot and compressed iron and magnesium-rich solid rocks. And the mantle is in combination with the crust makes up what is known as the lithosphere, as I mentioned in the name of the crust before. So the lithosphere will be all of the Earth's crust and part of the Earth's mantle. The lithosphere. This is the rocky outer part of the Earth and is made up of the crust and the upper part of the mantle, as I just said. The lithosphere is the coolest and most rigid part of the Earth. The lithosphere is then broken into plates, both large and small. And this part about the broken into plates is very important because when you get further into the subject of geography, there's something called plate tectonics, and this is a very large part of geography. We really should keep this in mind. The Earth's core. The core is referred to as the bariosphere, and this is the center of the Earth and is made up of two separate components, as we mentioned earlier. And these are the outer core and the inner core. The outer core is made up of nickel, iron, and molten rock, and they reach temperatures up to 50,000 degrees Celsius, and that's a crazy high temperature. The, the first of the two components of the core, the outer core, this is made up of molten rock as well as nickel and iron, which causes the outer component of the core to be a liquid due to its molten state, and it can reach astonishing temperatures as mentioned before. The inner core, the second of the two components. This is also made up of iron and nickel, but this component of the core is in a solid state. This is due to the large gravitational pressure exerted on the layer by the other above layers like the mantle and crust and such. And this causes that component of the earth to become more compressed and dense due to that gravitational push. And it's also the hottest component of the earth, reaching temperatures exceeding that of the liquid outer core as mentioned before. Types of rocks of the Earth's crust. There are three main types found on the Earth. Wait, before I go on, are you following so far?
Yes, sir.
Okay. Right. There are three main types of rocks found on the Earth. These are igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous rocks. This is a type of rock that is formed when magma is released from the upper mantle and it rises to the Earth's crust, where it cools then solidifies due to its lower temperature. So, you know how in volcanoes we get lava? The thing inside the volcano before it's released to the surface where we can actually see it, it will be called magma. And when magma is released through the mantle and it eventually reaches the Earth's crust, this is when it cools, and that's when it becomes a rock. And these rocks will be known as the igneous rock, as you can see here. After the molten rock has cooled, crystals are formed, and these rocks are called crystalline rocks. They can either solidify within the Earth's crust, where the formations are intrusive/platonic features, or on top of the crust, where these formations are extrusive volcanic features. Plutonic/intrusive rocks and volcanic/intrusive extrusive rocks. Intrusive rocks are also called platonic rocks, and these are formed from magma that is forced into the older rocks deep within the Earth's crust, which then slowly solidifies below the Earth's surface. Though it may later be exposed by erosion, extrusive volcanic rocks. These are formed when magma escapes the Earth's mantle through a volcanic eruption or oozing fissures, and due to the low temperature, the lava cools and solidifies. So, when volcanoes erupt, that magma that's no lava will cool and turn into rocks. Or when there are like open crevices in the Earth's crust around the world or what's not, it doesn't have to necessarily be a volcano for it to become for you to be able to get lava. So they can be open crevices on the Earth, and when the magma like seeps out of those crevices, which will be known as fissures, they can cool, and then they will also be cool and become rocks after they solidify. Public service announcement. Magma is molten rock inside a volcano or beneath the Earth's surface. Magma only becomes lava when it is above the Earth's surface. Because people often mix up what is magma and what is lava. But yeah, these are characteristics of igneous rocks. They can reflect light. They do not have any layers. They do not contain fossils. They are formed through the cooling and solidifying of magma. They go through a metamorphic and weathering process. They are crystalline rocks, and they contain different minerals like iron and magnesium. And many of these characteristics we covered earlier in what is the igneous rock. There are some examples of igneous rocks: granite, gabbro, basalt, diorite, pumice, peridotite, and sienite. It's an example of granite and basalt rocks, the two types of rocks that make up the crust of the earth. Granite, granite, gabbro, basalt, and diorite are mainly found in Dodoma, Ingra, in the Tanzania, and the shores of Lake Victoria, Rwanda. This is a fun fact. This is not something you need to like for sure remember, but you can never have too much knowledge, right? Sedimentary rocks. This is the second of the three types of rocks found on the Earth's surface. These are made when sand, mud, and pebbles get laid down in layers, and over time, these layers are squashed under more and more layers. Eventually, these layers are liquefied, turning the rocks into sedimentary rocks that can be formed in deserts, lakes, rivers, and seas. The sand, mud, and pebbles and any other materials that help create these sedimentary rocks are called sediment.
Yes, please. Words to know. Lithification is when the fresh sediment is deposited and compacted to create a fresh rock or a new layer. Weathering refers to the breakup of disintegration and decomposition of rocks, minerals, and soils by atmospheric conditions. Characteristics of sedimentary rock. They can contain fossils. They are found in layers which are called strata. They don't reflect light. There are non-crystalline rocks, hence why they don't reflect light. They can undergo metamorphic processes. They are formed when particles or sediment are accumulated, compacted, and cemented together. Now, referring to the aspect of it, can contain fossils. You have something like sandstone or a similar material that over millions of years is accumulated and compacted with the body of an animal, and eventually it basically preserves the bones of that animal. And through other chemical processes, the bones then become fossils. Uh, Also note that sedimentary rocks are essentially in characteristics, right? The characteristics, they're essentially the opposite of igneous rocks. So, types of sedimentary rock. Sedimentary rock can be further categorized into three types: mechanically formed sedimentary rocks, chemically formed sedimentary rocks, and organically formed sedimentary rocks. Mechanically formed sedimentary rocks. Clastic. This type of sedimentary rock is caused when pieces of pre-existing rocks, called clast, are loosened by weathering and then is transported to other locations. The transported material or sediment is then deposited in a basin or depression where it is accumulated, compacted, and cemented together to create a new rock formation. Types of mechanically formed sedimentary rocks. We have clays, gravels, and alluviums, all deposited by water because they're water soluble, um, or very easily carried by water, I should say. Moraines, boulder clay, gravel, all deposited by ice. Loess, deposited by wind, sandstones, and shale. Chemically formed sedimentary rocks. These types of rocks, like flint, are formed through the chemical precipitation method, in which a chemical precipitate which contains a chemical compound, for instance, calcium carbonate, salt, and silica, forms when the solution it is dissolved in, usually water, evaporates and leaves the compound behind. So think of like uh, limestone processes. Types of chemically formed sedimentary rocks. We have gypsum, flint, dolomite, borax, rock salt, lignite, and limonite. You'll be very familiar with rock salt. Organically formed sedimentary rocks. Similar to this would be more so limestone. Similar to the mechanical processes, organically formed sedimentary rock is formed by the deposition of material/sediment. However, instead of pre-existing rock particles, this sediment consists of leaves, animal materials, plants, and other organic debris. For example, soil. Then the deposited sediments are broken down, accumulated, and compressed to form the organic sedimentary rocks. Types of organically formed sedimentary rocks. We have chalk. Chalk is an interesting one because chalk is formed by the accumulation of dead, uh, you could say, plankton like zooplankton bacterium. Is something along that line. Limestone, coal, peat, and lignite formed from plants, coral formed from animals. Fun fact: the rocks underlying Barbados consist of sedimentary deposits, including thick shales, clays, sands, and conglomerates, laid down approximately 70 million years ago. Above these rocks are chalky deposits, which were capped with coral before the island rose to the surface. A layer of coral up to 300 feet, 900 meters, thick covers the island, except in the northeast physiographic region known as the Scotland district. Think of like St. Andrew, for example, just one of the locations, which covers above 15% of the area where erosion has removed the coral cover. The government has adopted a conservation plan to prevent further erosion. Metamorphic rocks. This is formed due to geologic uplift and the erosion of rock and soil. Um, uh, you know, this is a very interesting one because you can basically see this type of rock formations um, in America as a really good example, like in canyons and locations like that. At the surface, metamorphic rocks will be
Like the Grand
exposed to
Canyon?
Pardon me?
Like the Grand Canyon?
Absolutely, yes, please. Metamorphic rocks will be exposed to weathering processes and may break down into sediment. These sediments could then be compressed to form sedimentary rocks, which would start the entire cycle anew. Characteristics of metamorphic rocks. Due to prolonged heat and pressure, metamorphic rock tends to be very hard and tough. Any rock can become a metamorphic rock. They undergo the weathering process. Examples: sandstone to quartzite, coal to graphite, limestone to marble, clay to steel, I think that's supposed to be slate, garnet to gneiss. So this is an interesting process. Basically, what occurs is that through weathering and through immense pressure of it, being compacted, it then forms a different um, atomic bond and structure that basically transform it into a different type of material. You can think of it as a similar process to like what happens with coal turning into graphite, right? For example, it's a very easy to understand thing. That will be the end of the presentation. If you have any questions, please feel free to ask. If
If there's anything you want me to go back through or explain again, you could let us know.
yes, please. If not, you're free. You're free to go.
Oh, no, well, I have no questions.
All right, no problem.
Okay. Have a nice night.
Same to you, and thank you for the class.
All right, no problem.
Absolutely, no
Alright.
problem.
Bye bye. See you again.
Bye. When is the
Bye-bye.
other class?
Pardon me?
When is the other class?
The other
Next
class
week.
there's another class tomorrow at
Oh,
let me double
mean
check.
for. Oh,
I have to double check real quick.